Hello everyone, welcome to the maths. So this is the first video that I make. So day by day, I'm usually a teacher and I want to share the materials which I've made that helped a lot of students, and I hope it can also help a lot of people on the YouTube. So I'll try to upload a lot of videos regarding maths and maybe also later regarding physics. I hope those of you who are taking your exam or are struggling with your maths and physics can see this video, and I hope you'll be helped a lot. So in this first video, I want to talk about quadratics and why do we study it. So what is actually a quadratic? Before we begin, we need to review a bit on what we know about linear function. So linear function, as we know, is going to be a straight line. If it goes up, it's going to have a positive gradient. If it goes down, to the bottom right, it will have a negative gradient. And the equation for a linear function is always going to be y equals to mx plus c, and the usage is going to be algebra problems, rate of change, and also movement of object, but sometimes it can also be used for estimation, budget planning, statistics, revenue forecasts, and many more. That is regarding linear function. Now, what about a quadratic function? So a quadratic function is also called a parabola because it is shaped like a parabola. And the general equation for this is always going to be ax squared plus bx plus c. And the usage for a parabolic function is going to be motion prediction, where you can predict the motion of bullets, arrows, and also projectiles. You can also design bridges and arches. You can use also for computer graphics and animation, and you can also use this for optimization regarding budgeting, revenue, logistics, etc. So this is one of the examples where you use a parabolic function. So to design an arch of a bridge, you actually need a parabolic equation. And this is what I also explained before, where we use parabola to predict projectile motion. Suppose that some of you are an athlete competing for an archery competition, then sometimes we need to get a feel on how an arrow will move. And an arrow will actually move like a parabola. It goes up and then it goes down to the target. And one of the more interesting things that I want to share with you guys is going to be this one. Let's say that you have a graph of input and output. Let's say that input is going to be the amount of hours that you give for something, or the amount of labor that you give to something, and output is going to be the amount of productivity or the amount of results that you get. So what's interesting is that the output is not always linear to input, but sometimes it will follow a parabolic curve. So this is actually called the law of diminishing return, where adding an additional input will actually result in a smaller return or perhaps negative return. Usually it's studied in the economics. So this curve will be divided into three phases. The first one is going to be a productive phase. So in this case, the amount of input that you give will actually lead to an increase in the output. But in the diminishing phase, we know that additional input will lead to a smaller output. And in the negative phase, additional input will actually lead to a decreasing output. And again, the input can be study time, the amount of workers, spendings, materials, and the output can be marks increase, productivity, quality increase, etc. So in this case, I want to give you a simple example. Okay, let's say that you are studying for a math test, and then let's say you try to record how many hours you study and how many marks you get. So if you study from 1 to 3 hours, you will be able to increase your marks greatly. But if you study from 4 to 6 hours, it's not going to be too much because you are tired. But if you study 7 to 8 hours, then you will burn yourself out. You will actually decrease your score because you're tired during the test. So too much of something is actually not good. Okay? So there you go. That's our first video, yeah? Let me know if you have any comment, and don't forget to leave a like and don't forget to subscribe. So I'll see you on the next video. Thank you.